All right, so the main things that I'll be talking about in this narration are the improvement parameters, the machine functionality, the lessons learned, and the overall opinion of the project. So to start with the improvements, we did our retracting climb finger differently. We did a tension spring, which we connected to the bottom of the tooth and then to the top of the wheel. So it kind of provided that tension and pulled the tooth towards the top of the wheel and provided the clearance that we needed so that it could grip the stair, hold on, but also not too much clearance so that it couldn't roll on flat ground smoothly. So that's how we did the retracting climb finger. We did a few things to reduce the overall mass, right? So if you look at the bottom right side of the platform, we cut that piece of wood out because it was just didn't have much use, so that reduced the mass. And then if you look at the outer radius of both wheels, we try to make those not too big, so we made those around 1.5 inches. And then the thickness of the wheel, we tried to keep below 1 inch, and we ended up going with 0.75 inches. So that helped reduce the mass a lot. And then we also 3D printed a lot of the spokes on the wheel because PLA is known to be a bit lighter than some metals. So we did that for an extra weight reduction. Now, to reduce excessive component clearances by adding the ball bearings, we did include those, right? So we put one in each of the hexagon supports in the wheels to help with the shaft, and then we put them in the other required places, which was those two metal rods in the front right of the platform, and then one to the right of the sprocket, and then one to the left of the left wheel. So we had a few ball bearings in there just to reduce the most amount of friction we could and allow for a more smoother operation. Now, to improve the storage requirements, we were really, really close to fitting it all the way in the box. We found this as a bit more difficult task, right? But we still almost fit all of it in. We ended up being able to close about three of those little box doors on the top, but there was a little metal rod sticking out the top. So that was great. And then the assembly speed for the machine, that was great. We got it fully assembled in 2 minutes and 45 seconds, as you will see in the video. And which is below 3 minutes, which was the requirement. So we shaved off about 15 seconds off that assembly, which was absolutely great. Now, to talk more about the machine functionality, right? So the machine was functioning honestly a lot better than we thought. It was actually functioning great. The teeth, we were kind of worried about the friction that the PLA would have with the wooden wheels, but we shaved off some of the PLA so that it allowed for more clearance between the wood and the PLA, and that actually helped us a lot. So the teeth were sliding without much friction, which was great. The functionality of the drill was a little kind of here and there. The torque wasn't quite what we had expected from the drill. However, it was still enough to get up the stairs. So that was great functionality. The gear and the sprocket was absolutely wonderful. And then, especially on the flat ground, it was just moving really smoothly. Not too many bumps. We were once again worried about the friction between the teeth and the wheel, but it ended up being perfect. The teeth would just slide within the support and the wheel would roll smoothly. Now, some of the lessons that we learned a few lessons regarding the drawings. So we were a little disorganized with the drawings, and we learned a few lessons to maybe get those done before the assembly, because we kind of waited till during the assembly. So we definitely could have done those before the assembly. And then another lesson that we learned was to watch out for the clearance of the teeth, right? Because as you'll see in the video, one of our teeth ended up snapping off because it hit the platform, and then ended up being a torque battle between the drill torque and then the strength of the tooth, and the strength of the tooth ended up losing and snapping.
So this is our uh, computer-aided stair climber project. This is group 4.2. So this is what we got right here. We had each of these teeth was spring-loaded, as you can see right here. Comes in and out. We lost one during the filming of the video right here. Cracked right down this shaft, so that was a problem we had. As you can see, we've got 3 teeth on each wheel. A few problems there. And then we have 3D printed spokes that come out to the wheels and go to this center thing that has a rod going through it. Each of these supports, as you can see, they were busted from our fail, but right here they hold in. There was a third here that also broke. And then you can come over and see this sprocket. So this sprocket leads all the way over to the small sprocket, which is spun by this drill right here, as you can see. And this drill is attached by this rod. And then you come over to see our emergency stop, probably our smartest part of this whole thing. So as you twist this, so you have to pull out this little piece and then you can twist this freely. And when it freely twists, you get all the tension you need. And then once you're at a spot you like, you grab this pin, place it through the hole, through this gear, if I can get it, and then through the other side. And what happens, let's say we've got it as tight as we want to. Oh no, something goes wrong. You pull this pin and it releases, and then the tension is no longer there. So yeah, that's our whole project.
Now, the overall opinion of the project as a student assignment, honestly, the project was great. We learned a ton of new stuff. We learned a lot about SolidWorks, kind of a lot of file stuff like that. And most importantly, we learned a lot about the teamwork side, right? Because there was a lot of communication, a lot of, texting back and forth, seeing what everyone's doing, stuff like that. And then for the more physical side of the project, we learned a lot about the construction part or the fabrication part, right? We learned a lot about kind of some of the issues that come up with fabrication, and kind of how to resolve those issues and kind of just keep working as you resolve those, which I would say was a difficult part. Um, but yeah, it was honestly, it was a great project. We all learned a lot of information. We all learned a lot of communication skills, things like that. So overall, 10 out of 10 project.